All right, everybody, how we doing? Doing good? All right, we're recording. So, for those who really wanted to see, okay, yeah, okay, you guys are special, all right? I tell that to, do I tell that to everyone? I guess. You guys all mean something to me, okay? You guys are my students, my lab students, and I'm proud to be your guys' lab director, all right? So, anyways, let's get these dubs, all right? So, what do we have for today? We're going to go over Miller's theorem. I'm playing. No, we're not going over that. We're going to go over cadence stuff. Let me see. Cadence. Boom. Tools. My library. All right. So what did we talk about the last time? Oh, I know what we talked about the last time. Who wants the solutions? Or not a solution, but just a helpful tip. Okay. Let's see. All right, question of the day, how do I fix this? Display, right? Or E. Now let me just, I don't like the resolution on this thing. There we go. File, browse, my display options, the thing that we made together, right? Load from that, boom, and then watch the magic. All good. So we left off on this, okay? And then let me just show you the schematic, all right? Let's see, schematic. So I think we can probably use everything in this process. What's his name? A buddy of mine, Dylan, helped me out with figuring this out. So it might come down to understanding the beauty and the wonders of no-con, right? This little guy right here. And yeah, you see this this little guy right here? Because what happened was I had something like this, and I had this. Let me just do this. V bias P. And I don't know if this was supposed to do anything, but it didn't like that. So there we go. So that's the situation we have. So here's the bigger problem. Do you see this VSS right there? So, or actually, you know what? I don't think I'm going to call it VSS. I'm going to call it something different. I'm going to call it, let's cue it. I'm going to call this one res dum 1 or something. I don't know. Yeah, res dum 1. Okay? I'm just going to do this just for a sanity check, okay? No name conventions, just pure raw, just everything needs to work, okay? There, okay? Is that cool with everybody? How many pins do I have? 1, 2, 3, 4, 5. Cool. VDD sub. Do I have a sub in this? No, I don't, but it's good to have that, okay? Do I have a VSS in this one? Not necessarily. No. Well, technically I can, but I don't. But it's good to think about it, okay? Because we're going to design for your final projects, all right? But I do have these 3 outputs, okay? This is what I have. So let me check and save, okay? I'm calling this resistor dum, res dum 1, okay? So let's go to my symbol, okay? That's my symbol, right? My PMOS, right? V bias P, I out, I ref, sub, good? Everyone following with that? So let me tell you a few errors that I did. First off, do I have the original schematic? No, I don't. I deleted it. Yeah, I deleted it. Let me see. Tutorials. Yeah, I deleted it. Actually, let me see. I think this one I can show you. Let me show you this. So I had a situation where I had, it was a V bias P. It was this. You see this right here, right? But on the layout, remember how I had V bias P like right here? So it's treating the pin as like it has to color the whole thing. So basically, don't put the pin here. Put the pin like right there. That was my biggest error, okay? Does that make sense with everybody? So I could do this right here, but I don't think I want to. Maybe. I'll think about it. Because V bias P might be good for like biasing an op amp to the future, correct? V bias P, V bias N. What are the other biases, like bias 1, bias 2, bias 3, for when you're building like what do you call it, band gap circuits? Has Dr. Zhu talked about band gaps? No, it's okay. Yeah, band gaps is a great way to test your NMOS theory. Okay, so anyways, yeah, maybe if I were the lecture guy and I was introducing cadence, I would make people do this and then use these rails to power things in your band gap. Yeah, that'd be cool. Anyways, let me show you the good money making thing. LVS. Okay, this is the one that matters the hardest. Okay, so my LVS runs. Okay, rules. Don't forget the rules. Let it do its thing. Okay. Input, geometry, and text, correct? Then submit. Yeah, run it. Nice, it's running. It's a perfect time to look at my stream. Doing great. Me. Display. What? Oh, you guys are funny. Anyways. Woo! There you go. You guys like that? Clean LVS. That's what I want to see for every project you do. Okay, I'll talk about the final project anyways, sometime soon. But yeah, that's the PMOS, okay? So, you know what? I'm going to do something funnier. Let's get rid of that. What am I going to do for your PMOS times 5? See, NMOS, Costco, NMOS times 5 PMOS. What am I going to do for your PMOS times 5? Copy. Paste. Was it X5? Yeah, X5. Okay it. Actually, copy hierarchal, just in case. You never know. Update instances. Okay it. Let it do its thing. Go to your schematic, right? What are you going to do for your homework assignment when I publish it? I need to publish that very soon. This is my reference, right? Don't change that, okay? This right here is what I want. My current mirror, correct? Cue it. Multiplier 5. Okay. Check and save. Any questions about that? What am I going to go to your, let me see. Let me go to your symbol. I don't think you need to change your symbol because I think it names it for you, correct? Let me do this. Copy paste, right? You're going to do this for your homework. X5, right? Go here, go to your schematic, right? Everyone following how easy this is going to be? This is, wait, let me see. Something happened. Oh, did it update for me? I think it did. Something happened. Give me a second. I see what you did. There we go. Yay. You see the name right there? It already does it for you, okay? But if you want, do you like this right here? If you don't like that, it's okay. Well, okay. For those who have a OCPD like me, go here, right? Go to your symbol. I'm going to show you a trick. Here's your simulation, correct? Who wants to be perfect? Press M. Push this down. Bless you. See what happened there? Clean. Just to make your life easier, okay? But anyways, I don't need that one. What I needed was this guy right here. Where is it? PMOS times 5. Okay. Check and save. Launch. ADEL. You guys like that I'm teaching you guys things to make your life a lot easier? King of copy paste. I don't know. That's. I guess that's what I'm calling myself. I guess the students are calling me that too. It's not like it's like, okay, I'm not lazy. It's more like work efficiently. Okay. I want to make sure this is an easy thing. So this is my old simulation, right? 21 and 19 micron. Is that correct? From like the PMOS times 1. So I need to rerun this, okay? Let's rerun this. And then watch, it's going to jump to 100. Everyone looking? And there you go. Well, it's negative 107 times 5. That's the answer I want to see for your guys' lab 4. Easy lab. That's why I wanted to make it due tomorrow. But it wasn't because of this. That wasn't the problem. Let me see. Get rid of that. Get rid of that. Get rid of that. Get rid of this. This was the problem. The layouts. Okay? I don't want people to cry about this, okay? And I don't want you crying about this either. How do I do a times 5 for this guy? Just go here. Cue it. Parameter. Times 5. Or where's my multiplier? It's okay. Times 5. Okay. Any questions? You look like you have a question.
Somewhat. I'm trying to figure out how to word it.
So here's the original PMOS, right? The PMOS current mirror.
Yes.
Do you see this gate drain connected PMOS? And you see this gate connected PMOS, but the drain's kind of just chilling right there. So I need to multiply this by 5. Let me see, multiply by 5. Right, multiply by 5. Let me see, where's my layout? So for this guy, go to your actually, okay, if you're confused on that, that's okay. Oh, cancel. Oh, get rid of this. Come on.
But you don't need to have it as a multiplier to use the 5 fingers. Or
Yet kind of. I don't think you. Let me see. Maybe let me instantiate it one more time. Okay. Do I? I have a copy right there. I'm gonna go. I'm gonna press I. Wait. There we go. I. Oh, what the heck? Delete. Press I. Was it PMOS 1V, right? Where are my properties? Oh, right here. Because I can't do a multiplier there, right? Is that what you were like? Why did I change the fingers and not the multiplier?
more so in your schematic when you did the multiplier of 5.
Yeah.
You don't if you wanted to do it in your layout, so you had a multi.
Oh, so you instead of me, did you want me? Okay, let me. I think I understand the question. So let me go to my schematic. Were you OCPD'd about this instead of? Come on.
Can I have a 5-finger, say, MOSFET in the layout, but have a multiplier of 1 in the schematic?
Okay, 5 fingers in the layout, but multiplier 5 in the schematic.
A multiplier of 1.
Multiplier 1.
Can I use the multiple fingers to act as, maybe multiple MOSFETs?
I think I know what you're talking about. With Diva and Asura, for some reason, the multiplier doesn't really matter, and the finger doesn't matter too, because all it does was just multiply to your finger total width. So it just took account for the width. But Pegasus has a comparison, has a lot of other features, right? And maybe for it, the finger does matter, because maybe I as the designer give you the layout engineer, I want times 5, but you're I want like a big wide MOSFET, right? But you as the engineer, instead of 10W, right? Big long MOSFET, right? Why don't I just chop it into 10 pieces and just make 10 fingers? Personally, that's much smarter to do. But I, as the PhD designer, said, no, just try this. So Pegasus may tell you that the designer of the circuit wants you to do it like this, Mr. Layout Designer. I think I know what you're talking about. So you know what I'm going to do? 5 fingers there. So that we can keep it consistent. Because I wanted to do this because that would have been easier. But let me see. It's not going to show it to you. So do this. Both. Okay. And it shows you the fingers there. Is that cool? Because I don't blame you there. I would be confused too. I think I was confused when I did layout too. Then you can do the following. Oh. Q. There you go. See, because I can't change this, but I can change this. Okay? Is that cool with everybody? And then I got to change some other properties too. You see SD metal width. Tap contact rows. Okay, so who wants to help me solve this? Boom. Oh. Okay. You see how I have that edge right there? Okay. So I'm going to do it like this. And then let me get it up here. Boom. Boom. Is that cool with everybody? And then you see this blue right here? You probably don't see it. Let me just do this. Oh, wrong one. Blue. Everything blue is connected, right? Kind of. Well, we need to connect. Let me show you. This is going to bother a lot of people too. Okay. I think I know what's going on. There you go. I'm going to move this. Okay. So did Mingzhu went over, Dr. Mingzhu went over how to do, what do you call it, multiple fingers, or like how to connect them?
He did slightly in 421.
Okay.
That's what I was.
Okay, I understand what's going on. So does everyone who hasn't, do you understand what's going on with fingers and how to connect them? Dave? Okay. You see, okay, this is why I can't wait to use the whole 2 hours of today, okay? Because, anyways. There we go. Let's bring out my super sidekicks, pencil, and paper. All right, I want to make sure you guys understand what's going on because what's his name? I wish I knew. Oh, there it is, right here. So let me grab a couple markers here. So green for poly, just metal ones. Okay, should I do metal 1? Yeah, blue for metal 1. Okay, I like colors. And then let me be more consistent. Okay, show all view, all. There you go. Come on. Is anyone's cadence crashing like this? Yeah. Do you know that we also share the same Wi-Fi with the other students taking the exams right now, or that lockdown browser? Yeah. I'll use red. I'll use this magenta. Magenta for this squishy oxide. Squishy oxide, and I'll use yellow for the P tap, and I'll use, let me see. I would have made this an assignment for you too. Design an NMOS from scratch. What color is this? Is this orange? I think that's orange. What do you think? Okay, I'm gonna use the orange for our N, the, what do you call it? The yellow for our P, and the red for our oxide, okay? Is that cool with everybody? Okay, gonna get your education's worth, all right? But we should call this class something. Busy day, huh? Busy week. Project season. I like project season. Anyways, there you go. Bah. All right, for those who wanted to see it. 420L. It is April 9th, 2026. There we go. So, do I want to do it like that? Let me just. So you guys know that I'm gonna draw a gate. I feel like I should have drawn it the other way. Okay, this is my oxide. Okay, I feel like yeah, I should have drawn it the other way. Right, that's my oxide. Right, that's an NMOS or something like that. Well, it's if I wanted to make it an NMOS, you use that N plus layer. Right, is that correct? So this is N plus, like mask. Right? And then this right here is oxide. Cool. And then how about my body? Have that somewhere right there, right? But then I have to use P plus. And why is it P plus? Because the NMOS, the body goes to the P sub. Is that cool with everybody? Everyone understanding the fundamentals? Wait a second. Maybe I'm blanking out again. Come on. Come on. Y'all, we're getting call it, what's that thing? There's a term. Stream sniped. There we go. Do you see this purple? That purple for our N well. Guess what I have? Purple marker. That's a bad marker. I don't like that. Something more purple. Is that cool? So that means my method. I'm having a mental moment right now. This is N plus, right? And then this right here is P plus. Everyone understand what's going on? Yes. The body is of the PMOS is in an N well, right? Right? N plus. This whole well right here. So that means the taps right here are going to be P plus. Make sense? Because P-type silicon is holes. There's a bunch of holes, so we got to put a bunch of holes. Cool. Anyways. So how do I do it for a multiplier? Let's just do 3. Okay? So what's the first thing I'm going to do? This is what you do as an engineer. Okay? Draw this really long piece of oxide, correct? It doesn't do anything right now, right? Until we do the following. Yeah? When there's poly on top of an oxide like this right here, now we have transistors. It's pretty cool, right? Color that, color that, color this. Cool. Now, because this is a PMOS, right? PMOS well. Okay. And then how do I make sure? Actually, let me just do this. Body of the PMOS, right there. Right? Body. Actually, extend it a little longer. What's the body of the NMOS again? Or a PMOS? N well, right? So we need an N plus mask, right? N plus. So now, boom, that's N plus. Everyone understand what's going on? And then this right here is our PMOS. Put that P sub, or that P mask, right? Everyone getting it? I'm not going to draw context unless you want me to. Now you have this gray marker here. For this N PMOS, right? If I want to have the source connected to the body, right? What do? Just that, right? Cool. Then how do I have the drain? Like, well, the drain's just existing, just goes down here. Make sense? And then the gate, well, I would just tap here and just go somewhere else. Make sense? Cool. So for this, let's just say it's going to be a multiplier of 5, right? So that means, what do you call it? It makes me want to talk to you. Let me see. This goes up. This goes up. This goes down. This goes down. Okay. So I'm going to do the following, okay? Can you agree that this right here is the source connected to the body, right? And now we need the drain, right? It's going to go down like a waterfall, right? Right? But here's a transistor here, right? This can also be its drain too. Does that make sense? Right? Transistors. You understand what's going on, Dave?
Trying to piece it together. There's a lot of information. I don't know about that.
I think we went over this like I think the third or fourth week of school, right? And
Yeah, that's what my question was about. Like, if you have the multiple gates, it makes multiple transistors, right?
yeah, multiple transistors, yes.
Yeah, because I tried doing that for my 421 project for the Smith trigger. I had like the two NMOSs of the schematic right next to each other, and I tried to use the multiple fingers to like connect the drain of each one.
Okay.
But I got errors in my LVS, so I probably just did it wrong. But
Is that good? So we can connect these two, and then it would look like that, right? So this is like, oh, you see this space? This space right here is like, I don't know, L big, right? We're losing a lot of space, right? We can sneak another transistor in there, correct? So space is money, right? If I give you a box and I tell you to like stack it like Lego style, or like, what do you call it, grocery carts, right? And you want to stuff a lot of things in there. Of course you want to make sure every space is taken count of, right? This is space that's wasted, right? That's going to cost money. So instead of doing this, we do it like that. But I actually want to simulate your problem, okay? So we can fix that, and then would it be lab 5? Actually, see, lab 4 is where I wanted to do the multiple fingers. You see, that was my mind process. Okay, we're going to simulate that. Anyways, everyone understand this one? Everyone knows what's going on with this? Then I'm going to just do this, right? And then do this. Cool. But you know that these, drains are shared together, correct? So I'm going to do the following, just to give me some space, okay? You may have to do this. Is that connected? And then I can have a pipe going down here. Waterfall. Cool. How about the gates? There's a weird trick you can do as an engineer. And remember, poly is a wire. Okay? Poly's a wire. You can do this. Is that cool? And now I have a place to escape. And then I can put this big tap right here. And then I can have a blue layer right here. Boom, escaped. Everyone understand what's going on? What if I put a blue right here, like a blue square right here? I can get out of here, right? But I can't cross that wire, right? So I may have to use another layer, like, I don't know, metal 3 or something like that, which would be like, do I have a marker? Let me use this pink right here. I have to use a via, right? I have to use a via to get out there, and then I can metal 3 or metal 2. Metal 2, 3, 4, I don't know. Does that make sense with everybody? Because I can't cross wires. That's where multiple levels, like multiple metals, help out a lot, okay? So that's what I want to try and show you guys right here. We're going to copy this. You guys like having active lab lectures like this? Makes it feel useful. Wish it was done in the lecture instead. Well, not lecture, but you wish... I don't know. Anyways. Can you copy paste? Actually, don't copy this one. There we go. Oh, there we go. Copy paste. So let me show you a trick that I learned from my internship. If I press, see, I don't think it's gonna. Let me see. Let me see if it's gonna let me. I want to do the. Okay. I want to see if I can do the weird trick. I want to show you a mosaic. No, it's not gonna let me do one. Darn it. Would have been nice to show you. Create, edit, copy, No, it doesn't pop up. That's silly. There's this button where you can copy a bunch of layers. It's really, really cool. Advanced. Convert to mosaic. I don't think it did. I don't think it did what I wanted to do. I don't think I like that. There we go. Anyways, so what I'm gonna do right here is I'm gonna draw metal 1. Okay, someone drew on, like, I don't know, oxide and did this, and I was like, why? Don't do that. Click on metal 1. Okay. This is how I do layout design. Oh, come on. There we go. Zoom in a little bit. Then I stretch. Come on. Stretch. Escape. Stretch. S to stretch. S to stretch. There we go. Okay, stretch this out, right? So I was going to try and show you, but it can't do it right here. Just copy, paste, connect this one, and then put it right here. Copy, paste again. Oh, there you go. Boom. Is that cool with everybody? What am I going to do with these guys? Do this. Do this. Cool. Let me just K this for my reference. That's 0.2 micron, correct? Right? I kind of want to keep things consistent. So if I wanted to, I can do the following. Let me see if I can Q this. Q. Attribute. Height. Let's do this as 0.2. Come on. Oh, come on. Oh no, come on. Come on. 0.2. There we go. Did everybody see what I just did there? Okay. Do you guys remember how if wires are a little too skinny, like this, you can burn the wires? So it's good to give it a little more space to, like, it's going to pull not 20 micron. It's going to pull 100 micron now, right? Or like 1 milli if you want to. So make sure the pipes are thick, okay? Let me see. Let me see. Parameter. It's folding threshold. I don't think this process tells you the current, but I remember in like another process, there's a calculation. It says how much current do you think you're going to sink? And if you put like 500 micron, it'll give you the right width all the time. It's really, really cool. But no, this process isn't as cool as I wanted it to be. So anyways, what do we do next? Connect the gates. Let me see. Poly. And then let's connect the gate like this. Boom. Oh. Poly. Boom. Boom. And let me just make it this thick. Is that cool with everybody? Any questions? And then what about the bodies? Copy paste. Can you copy paste? Boom. You guys like this class? Boom, look at that. Looking nice, right? We're done. Cool. Save. And then how do I get rid of these markers? Close. Shift K. This is why I tell you guys, if you want to put bind keys on your homeworks, some of you guys do it, because I forget too. Okay, keep these little checks. Okay, Control C, Control V, or Shift K, D, P, Q, I, O. What does O do? Via. So keep these little things in mind. All right. Anyways. Oh, don't forget this guy. My output. Is everything making sense? The waterfall? So I can put the waterfall going somewhere else. So now, I didn't do anything with the resistor. So you see that's your answer right there. Cool. Pegasus, DRC, to see if I drew it correctly. Run directory. DRC. Boom, choose, and I think run. Boom, boom. Let it do its thing. Submit. Yes. Now I know what to do during my off time when it's running. My favorite streamer is on live. Yo, clip that. I'm 100. The heck? Oh no, we're not getting any dubs tonight. Let's see. Metal to metal spacing must be greater than 0.1. By the way, please do not, on your assignments, don't just say, hey, I got a DRC error and I don't know how to fix it. Here you go, David. I'm gonna start grading harsher now. Okay, instead of the minimum 8s that I've been giving out, I'm gonna start giving out like 5s. Okay, what's the first thing you gotta do? And please document this. Okay, if you truly can't get it, I don't know. Click on the errors. Okay, what's it telling me? It tells you what to do. Click on this. Let's see. Oh, what the heck? Oh, I see what's going on. Let me see. Oh, this one's annoying. Yeah, you see that? Let's do K. See the problem? Okay. So, what I'm gonna do... Think it's gonna bother anyone if I do this? I don't like it either. And then let's just draw more poly. Actually, no, don't draw poly. Stretch. Guys like how lazy I am. Save. What's the other error? Soft check. P substrate missing stamp connections. How do I fix this error? Anyone remember lab 2? Right? Remember that annoying error? You're going to see, based off lab 2, when David said it's okay, because the way to fix it is by putting a P-tap or an NMOS, and boom, your problem's fixed. It's just basically saying, you sure you're not connecting to the substrate? I just want to make sure you know. But it's okay, because this piece is going to be used in a future piece. Okay? Make sense? So I'm going to rerun this. Let's check our dubs. Sad face. Oh, whoa. What? I thought I was already signed in. Well, can't send my OO. Boom. Problem's done. Any questions? And that's an okay check, okay? That's what I want to see for your LVS. You're going to get this problem on the LVS. For those who aren't showing up, I have it on Twitch. I have it on record. Please watch the videos. Don't come complaining. I already had one person who's like, how'd you fix that? Did you watch the video? No, because I didn't think. Come on. What's the next thing we do? LVS so we can go home? And guess what? I already had it all set up. My LVS runs, the rules, input folder, submit. Let's check my comments again. Chat. Log in. Nah, I don't want to log in. Nah, screw that. Oh, I got an OO back. Let's see. Is that correct? Is that correct? Did it run? Finish normally. I guess it ran. Let's run it again. I'm having a moment. Okay, it did run. Okay, you see how it disappears right there? You see that my DRC runs right here, and it disappeared. Now watch it pop up. It's gonna pop up again in this same tool. Okay, let's look at it. Okay, you see the folder just pop up? There we go. Okay, sanity check. We're good. Any questions about that? Now you can do your PMOS. Now you can do the assignment. Now that we fixed that dumb little error right here, that resistor that I'm calling resdum1 with that no con. really does do a lot of wonders. Anyways, so that's your Lav 4, okay? Oh, the LVS for the fingers. Let me see. Wait, oh, wrong one.
I was using it as two like separate NMOS groups.
Let me see. So are you? Let's do this. I'm gonna change the rule, okay? Multiplier 5 with one finger. Okay? So that's what you wanted to see. I want to see that too. I want to know, does that matter? Okay. Nothing's changed. Let's LVS it because there's no reason to DRC it. DRC is for painting things. LVS is to make sure the net lists work. Come on, baby. Boom. On. Doesn't matter. It doesn't. Okay. So it doesn't matter. Okay, so you can use the multiplier or the fingers. Okay, but anyways, yeah, I wonder what error you were getting then. I want to see that. Personally, yeah, just
See if I can find it.
okay. Anyways. I think what I want to do now is, well, now you can do your assignment now, okay? Actually, let me be more special, okay? NMOS. Did I do a layout for the NMOS? No, I did not. Okay. I'll give you guys the gift for those people who don't watch the videos, or I don't know. Okay, wait. Layout. Layout. Okay. How am I gonna do the NMOS? So let me go to my PMOS, right? Remember that PMOS layout? Right? What am I gonna do? I'm gonna copy this, and maybe copy this, right? Actually, copy it right here. Okay, everyone's seeing what I'm doing right now, right? I'm gonna F to zoom out like this. I'm gonna click on this, right? Highlight that blue rail. You're gonna do this for your Lab 5. I'm gonna make you do this for your Lab 5, okay? For multi-channel systems. Okay? So shift click, right? Shift click here, correct? And shift click this one. Is that cool with everybody? All these rails are connected or are selected. What I'm gonna do next is I'm gonna super zoom into this right here. You see the origin right there? I'm gonna press C to copy, and I'm gonna click that origin. See how I can like collect this stuff right here? You see that rail system? I'm gonna go over here. And now you see how it's orthogonal now? Or I can move in, or not orthogonal, I can move in, come on. Okay, there we go. Don't freeze on me. Click right there. Now I have the same rail system, my footprints ready, okay? And then because this is V bias P, correct? For, V bias P. Does it matter? I'm thinking of something right now. Because this is the reference, correct? And you know how I did the ×1 and the ×5, what do you call it? The PMOSs, right? What I'm claiming is that if I copy pasted this circuit here and the ×5 together, that this voltage should be the same for both those circuits. Right? Because this is the one that's floating. This one doesn't see V bias P. V bias P is buffed by this guy right here. I'll show you an example, okay? Because now I actually want to see it. Anyways, I'm going to go to my schematic. NMOS. Did I use the same resistor? 15K? PMOS? Just want to verify. I use 15K, okay. So what am I going to do here? Can you copy paste? I'm going to copy this right here. So how do I copy paste things from different cells and make sure they're in the right spot? One thing I can do is I can do that origin trick again. So select everything I need, right? Right? Okay, I have this rail. I have this reference here. Yeah, that reference. And that's it. So I'm going to go here, press C, and I'm going to click on this origin, okay? That's your reference, your home, your ground. Okay, now the thing is floating. See? What about here? If you click on this, it should be in the same spot as we left it. Super cool. I did this a lot during my research. Okay, now it's the same resistor, okay? Now, you guys are going to get the good treatment tonight. No. Because the NMOS is at the bottom now. This is what you get for copy pasting, David. It's okay. Come on. Save. There we go. I don't know why it keeps crashing like that. So what I'm going to do is that resistor is at the top. So let me just get rid of this. Okay. Let me get rid of this, and I'll leave that there. I'm going to move this up. Okay. And then what am I going to do down here? Oh God, I think I had a eureka moment, but I don't think I can show you that. Oh, come on. What the? NMOS. Cool. Height. Why is it making me create a Shift K? Hide. Okay, something's wrong with my cadence, y'all. Yeah, sure. Don't you guys like it when cadence crashes like that? That was weird. NMOS, layout. I to instantiate. View. What do you call it? NMOS. There we go. Is that the correct view? Yeah, AUCDL. Hide. Man, look at this. Oh, wait, what the? Whoa, 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 whoa. Cell. Mimcap. Oh, it's doing something weird for me. Layout. I'm falling asleep, everybody. Anyways. Cue that. Boom. Parameter. Gate connection. Top. SD metal width 200. Let me see. What else can I do? Body type. Detached. Tap contact rows 2. And I'm going to put the bottom tap. Okay. Is that cool with everybody? You see how it's going to complain right here? Wait a second. Don't do this. Get rid of that gate. No gates. It's naked now. Cool. So I'm going to put this. Let me see. Does the polarity matter? I don't think polarity should matter, right? I don't think it will. Okay, M this. Cool. I'm going to stretch this. Boom. Where am I going to stretch this to? Right here. Oh, come on. move, zoom right here, S. Make this a little prettier. Cool. That's connected now. My reference. And now I need to connect my gate. Do this. What's my favorite number? Or not favorite number. 3 by 3. From N1 to the poly. Is that cool? And I'm gonna do the following. Boom. Is that connected there? Kind of funny looking, but because that goes up. You know what? I'm gonna do the following. This might create a capacitor, but who cares? It's not gonna create a capacitor. Oh, that's ugly. Oh gosh, I don't know if I like that actually. Okay. There we go. Much better. Cool. Everyone happy with this? Or not? I don't know. Now I need to connect the gate drain. Okay, gate drain connected diode, right, to this resistor, right? Right? And this is my body right here. So I'm going to connect this with metal 1. Boom. And boom. And fix this error right here. Boom. Is that my NMOS right there? My reference, right? Body's connected. What do you call it? I need to connect this to, what am I supposed to connect this to? The substrate. Oh no. As a teacher, I failed you. Because I think I want to teach everyone the standard, okay? There you go. I want you doing this. Okay, maybe the NMOS might be a little challenging. I thought the PMOS would be hard. This is what I want you guys doing for your homework. Big sub right here. Subscribe. Okay. How am I going to connect from here to here? Control P, sub, keep first name, create label, hide, boom, 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 sub. Anyone subscribe? Mods ban him? What? Want popularity? Buy? What the heck? Got a bot in chat. Hey, someone chat. Someone kick him out. Kick him out. Anyways, I'm gonna use a via to go to metal 2. M1 to metal 2 to metal 1. That's my favorite number. 3 by 3. Let's do 5. 3 by 5. Is that wide enough? I think I like that. Do you like that? What do you think? I like it too. Hey, I'm streaming now, so you can just go to your Oasis. They're just like, hey, I'm still in class. Oh, thanks. You're the bot. Yeah, you're the bot. Go leave. I'm like, no. I'm like, no, thanks, man. Have a good day, okay? No, I want to take the whole time for this class, all right? Because this is very valuable stuff. Take care. Anyways, we're on metal. What do you call it? Whatever this is. Let me just make it nice. I like it when it's a little flush. Like that. It's okay. Is that cool? So what I'm going to do is I'm going to do metal 2. I'm going to do this. Make a... Oh, that's via 2. Make a strong connection, okay? And I'm going to do the following. There we go. How long is this? Actually, you know what? I'm going to show you guys a cool tool. 1 by 64, 0.64. If I press O right here, right? There should be a way. Yeah, there you go. 0.64 by 1. Watch this. Flush. You know what I think? You know what I'm thinking now? Because I have OCPD. I don't think it's gonna like that, but let's try it. Oh, think it's gonna like this? 0, 5? No, it didn't like that. No, it didn't like that. Ah, that would have been cool. Let me see. Let me just measure this again. Wow. Okay. Yeah, it's not gonna like that. Whatever. Fine. Boom. Connected to substrate. Cool. Now I need to connect this guy to VSS, correct? And then this rail right here was VSS. VSS. Do you see how I have metal 2? Right? Don't do metal 2. Do metal 1. Someone literally put like a big metal 2 rail. I'm like, why would you do that? Just do it like this. And ideally, it'd be nice to have like the names on the right side, so it's easier for you to identify. You can have it here, but then it looks messy, because then when you're trying to connect other things, I don't know, it just depends. You build your rail systems the way you want it to be built, okay? So that's my VSS. So what I'm gonna do is I'm gonna S this, king and copy paste. Watch this. I'm too lazy. Just go right here. Boom, baby, let's go. And then do you think it's gonna be a DRC error? Let's just give it a little, click this, press a little M right there. How far are we from here? 0.45? Should be enough, right? There you go. You guys get so good at layout, you start memorizing all these rules, the design rules. It's pretty cool. I like it. Anyways, is everything looking good? And then this right here is going to be our IREF. So I'm going to do this. Oh. R, I, ref. Like this. Oh, come on, escape. There we go. I'm going to control P, I, ref. Okay, I think this is going to be a good assignment, y'all. Oh, there we go. Oh, come on. Q. Do 0.5. Just make it look a little clean. Let's do 0.2, whatever. Everyone seeing what's going on? Cool. Now I got to do the other PMOS, correct? Or NMOS. So what am I going to do? King and copy paste. Boom. Like that. Cool. And you see how this VSS and this VSS share the same rail? Right? So what am I going to do? Yeah. Lazy. Yeah. I think I can do the following. Make it a little closer. Stretch it a little farther right here. Boom. Is that cool? And then this would be, the gate is connected like this, so I could do the following. Everyone's going to have unique layouts. Do you like that? I think I like that too. Let me press this. M1 to PO, rows, 3x3. I like 3x3s. I think it looks nice. Did I hit it? Yes, I hit it. Boom. Hit that collat. Okay. So the question I think I might get asked is it better to draw a poly wire or a metal wire? Personally, so poly, what, I forget what the full name is, poly something. It's a resistive wire in a way. You can use it. But it's better to use a metal one. Because metal one has like, I think in like a sheet resistance that's like, I don't know, like 4 ohms per micrometer or something like that. It's very small. It's really nice. It's literally like a metal. But poly, it's like what do you call it? Let me just see. CMOS poly layer. Polysilicon. $20 to $40 ohms per square. So it's a little more. Okay. I think I gave you guys the design rule like list on the lab thing. So read that manual. So would you rather least resistance? Okay, less parasitic. So this is what I would do. Just connect it like this. Boom. Nice. Any questions? And now this right here is my IREF. So do it like this. Stretch it. Boom. And that's it. Control P. I out. I out in lowercase. Cue this. 0.2. Emit. Boom. Any questions about that? And then IREF. I out. V bias N. Where's V bias N? This right here. V bias. Wait. V bias. Oh. Bias N. Okay. And then you know what? I think I'm going to do the following. 0.4. Now Q. 0.2. Okay. Boom. Because maybe I want you guys doing this for your actual project, maybe if you want to. But I'm showing you what I think might be good. But you tell me if I'm wrong. V bias N. Okay. And then I'm going to do O. And then how long is this? Actually, let me see. How big should I make V bias N? Oh, I see. Single. We're going to go from metal 1 to metal 2. And I'm going to make it, so the width was 0.4. And the height, yeah, let's make it 1. That's fine. You guys like cadence? Yeah, when it's not slow. Weirdly enough, it's better now. So I'm very happy to see cadence is still alive here at UNLV. Okay. So I'm gonna do something funny. Okay. I'm going to K this. How long is this? 1.54. And this right here was 1. So what I'm going to make you guys do, if you guys can try. One. Okay, there we go. I have to fix my PMOS now. Because this one here was defined as V bias P. Remember from the last class, V bias P is this one right here, right? So I'm going to do the following. And how long is this rail? 1. And then I'm going to do another one right here. 1. Cool. Copy, paste. Copy, boom. Paste. Is that cool? Everyone's seeing how cool this rail system is going to look? It's going to look legit. Okay. Now I can stretch it right here. And now I can do the following. Copy, paste. Boom. Does everyone see what's going on? So now let me do something funny now. Okay. Move this. All pins need to be on metal 1, correct? Right? M. Boom. Then I can do this. Oh, cue it. 0.6. That right there is your bias. Okay, that's a strong bias, so you can put that into another transistor. You have like, I don't know, 20 other current mirrors. You can bias with this pin right here. So if I wanted to bias another of these NMOSs in the future, like there's an NMOS right here, right? How would I bias it? I would just pull the water from here and boom. Is that cool? Instead of having to go like snake around like, wow, I have this waterfall right here. I can pull from the water well. All right. This is my V bias N. This is my V bias P sub VSS. You see how things start coming to shape. You know what? I don't think I can waste too much space. Because here's me as a designer, and I think I'm gonna do the following. You can't if you want to as well. I'm gonna establish a standard right here. I'm gonna make this a little closer because I don't think it's gonna matter too hard. The voltage between this and this, I don't think it's gonna matter. Famous last words. It's okay. When you print the chip, yes, it's gonna matter. Okay, that's where trials and errors. When you're a research student, you're gonna do like, oh, I'm gonna do it like this, and then I'm gonna do like you. This can be a thesis. The spacing between the metals and biasing and seeing the couplings between two metal layers. That will matter. So do a study on that. That can be a thesis topic. Okay. So, like, what I'm doing right there is like a tech thing. But if you want to research that, be my very guest, okay? Thesis topic 1. Oh, I love cadence, y'all. You would print this, cost like $10,000. Get your professor to buy it. It takes about a year or 6 months to print. Yeah, then you have the wire bonder. Boom. We just hire. I'll talk after hours. Mods ban him. Cool. 2 viewers. Who's viewing my stream? Anyways, Control Shift K to get rid of that. You think this is ready? I think it's ready. Okay. So what I'm gonna do, save, options. No. Pegasus, DRC. Run. See if I remember my password. Oh, that's great that it what's his name blocked my email thing. Don't want to have to like, what do you call it? Do something funny. Twitch. How do I do this? 1, 8. There we go. Oh, heck yeah. Nice. I've messaged. How do I drop a turn on shield mode? Anyways, I don't want to mess with that. Our DRC just came back. Soft check. What happened here? Oh. Remember that NMOS thing or the PMOS thing? Or not PMOS, the substrate thing? I have this waterfall here, right? This is the dilemma of the design engineer. Would you rather this VSS be shorted like this, or would you want the substrate? Or actually, you know what? I'm lazy. There you go. Actually, no, I'm double lazy. Click here. Click here. Oh, come on. Is that metal 1? Cool. And then let me do R metal 2. Boom. 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 Now my bodies are connected. I forgot to connect the body. Okay. So let's save. What was my other error? Let me see. Oh, it was just that one. You see how one little thing can pop up like 1,000 different errors? Let's check my subs. How are we doing, chat? No one's in chat. Just one viewer. It's okay. Anyways. Is that clean? Yeah, looking clean, huh? All right, let's go to my LVS because that's what matters, okay? Do they both matter? Yes, they do. But anyway, submit. Run it. Did it run? Come on, let's go. Let's go. Dang it. Current mirror. VSS and sub. VSS sub. Something happened. VSS. Ha ha. Remember this thing? Come on, let's see if we can fix this one. Res, dum, and I don't know. Right? Separating that, and then what am I gonna do? Basic. Oh, come on. Basic, no con. The thing to save me. Boom. Is that cool? Can I stretch this? Yes. Move. There we go. No, all the resistors have that third terminal, but there is this right here. You can do res ns poly _2, and it gives you the 2-terminal one, but you're still gonna get that error, and I don't know how to fix it. I really don't. See, this is the headaches I don't want you guys seeing. Okay, I want to make sure this class is fun. Okay, so res dum is that. V bias n, just in case, you never know. Put that there. Sub VSS sub. Okay, I think we're good. I think we are good. Run that again. Rerun. Oh, hope this works. Why'd you think I'm extending the assignment another week? Other than I didn't get it published in time. Headaches. Comparison shorts. In the layout, it's a short. It's sub right here. You see. Let me see. What am I running? Get rid of that. Okay, that's my PMOS. Get rid of that. Was I running the right one? I don't... See, this is my fear. Okay. No, that was correct. Let me just click on this. It'll open the window. Okay. Okay, that's a lot. Sub. It's the whole thing. Layout pin sub. In the layout is a short, and in the schematic sub and res dum n. Oh gosh. I think I know what's going on, but I don't want to say it. I really don't. You see, this is the painful part. It's shorted in the. It's shorted here. Schematic net. What did I do? Let's see. Symbol. VSS sub, boom, boom, boom. Okay. Schematic. There you go. It says this, and this are all shorted together. Oh no. Please don't be this. This shouldn't be the problem. No. It's saying that this, even though I named it something different, is somehow still connected to the body. You see the problem? Rawr. If I'm getting this error, because I need to make sure you guys can go home, no frustration, copy paste, or not copy paste, understand what's going on, and cadence is fun. Okay, I want you guys doing some advanced like op amps, not having to struggle with one little LVS. Did it run? I think, I don't know, man. That's a dub. This is clean, okay? When you see that, you're done. No more. Publish it. Go home. I think I see a future problem. So what I'm gonna do right now, because you're gonna have to do this for your final projects. I'm not so sure. That's why I made it optional. I'm gonna give everyone that extra week to do the optional problem. Okay? This is ready for fabrication, okay? I'm gonna do the following now. I'm gonna create a new schematic. It's gonna be called My Current Mirrors. Okay? Layout. Okay, I created a layout. It's fine. But I'm gonna do the following. I'm gonna instantiate that what's his name? My library. Right? I'm gonna instantiate current mirror NMOS, right? The thing I built. Is that cool? Now I'm gonna instantiate that PMOS times 5 I built. Okay? And look how the rail system works. Boom! Ain't that cool? Things start connecting together. But you see, I did some other thing. I made the NMOS my master, okay? So this is going to have to follow whatever this is. So I'm going to go into... can I double click into this? Oh, I can. Don't do that. Control E, Control E. Oh no, I don't want to do that. No, escape. How do I get out? Edit. Hierarchy. I don't want to be in this hierarchy. Because if you edit this, it's going to do some funny things, and I don't know if I want you to do that. Is it Shift? Control E? Not Shift E. See how it's selecting things here? I don't want to do that. No. Okay. So let me just go to my current mirrors, okay? My current, where's my current mirrors? Where'd it go? Oh, I didn't even save it. Oh, no. My current mirrors. Don't you just like it when you copy paste things? And there you go. NMOS. There we go. Same thing again, okay? Then this is my master. This right here is going to be my PMOS. Boom. Come on. Oh, come on. Do you see my little errors? There you go. Boom. Cool. Don't double click. I'm going to save. So I'm going to go to my PMOS time 5 layout. Because I think I'm seeing a big problem. And I want to make sure I fix that right now. Actually, you see this is my B bias P right here, right? Correct? So I'm going to do the following. Remember how I did it for... Let me see. Library, NMOS. Here's my master layout. Okay, it's okay if you do this, okay? I encourage the copy paste. See this V bias P? Or V bias N, V bias P? So I'm going to make this one my V bias P. Okay, so that's one. Come on. This right here is going to be my... That. 1.54? 1.54? Yeah, fine, whatever. M for move. That's my V bias P. And then what's the length of this? 1. So I'm gonna copy. Yeah, that's interesting. Okay. Copy, paste. No, I didn't do 0.1. I did 0.5. Everyone's seeing what I'm trying to do right now, right? I'm gonna move this V bias P. Actually, where's the pin? Where is that pin? Let me select. What the? Which one was the pin? Was it this? It can't be. Don't do this. This is the pin right here. Put that right there. I used the wrong metal. There we go. Okay, that's still connected. Cool. Okay. So I'm gonna go here. I'm gonna queue this. I'm gonna do attribute 0.7 M. Everyone's seeing what I'm trying to do. Okay, and now I need to make sure that this is electrically connected to that, right? So what am I gonna do? I'm gonna do this. Copy this rail. Copy, Control C. I'm gonna click right here. Put it right here. And then I'm gonna tell everyone to do this, and you have to promise me you do this, okay? Please save every time you do something crazy. Because if you don't save, you'll lose all your work. Or not all your work, you just lose the work that you work hard. This software is hypnotizing. It's like you're gonna grind so good, you'll be like, yeah. You're gonna be locked in. So locked in you're gonna forget to save. Who's done that C++ assignment or Quartus and you forget to save? It hurts. I think LT Spice hurts the hardest too. You're working on the best simulation, and then you save it as a different file, but you forgot to save your original file, and somehow it disappeared, and you're like, no. Anyways. I'm going to do the following. Boom. Make this long rail. Okay? I'm going to copy this. Yeah, call me the king of copy-paste, everybody. Because... That's I think that's my motto for the PhD year I'm gonna be doing. Anyways, I'm gonna connect metal 1 here. Yeah, because Dr. Baker's the king of trivial questions. He loves asking like, "What's this? What's that?" Boom, boom, boom. Me, I just like making things work. Okay, easy. I think that's good right there, right? Save. If you're not feeling confident, by the way, if you do a little edit like that, right, don't feel bad about having to DRC and LVS. Personally, don't be afraid, okay? Start DRCing all the small stuff like this. This is right here is a DRC. I'm going to DRC that PMOS again. Even though I did a little bit of edits. But if you're not feeling 100%, DRC it, okay? Make sure everything works, okay? Soft check, what does that mean? For the PMOS. That's okay, right? Okay? So that means we drew everything we drew is correct. If you're not feeling confident about the LVS, that's fine too. Okay? You can run the LVS again. Okay? Let's check what chat's saying. No one's saying anything. It's okay. Anyways. Come on, baby. Let's bring this home. Bring this bread. But I think I need to check something else. Even though I saw that, I think I see a bigger monster coming in. That was my PMOS right here, right? Let me go to my schematic. Remember how I did that res dumb right here? I think this has to be. I think that has to be sub. You see how that sub pin's right there too? Personally, I think... Let's run that DRC again. Or LVS. Okay? We want to attack this from the very root. Okay? No more headaches. And I appreciate your guys' time, by the way. Doing this stuff also helps me in my personal research and endeavors. All right. Give us the LVS. Layout pin is sub. Schematic, it's open. You better not tell me. No. It's saying... let me see. Come on, Dave. It's there in the layout. It's saying this blue rectangle. If I queue it, let me queue it. Connectivity, no. It's saying this blue rectangle. Let me queue this. P1 property. This is here, right? But my schematic, it's an open. Please don't be this problem. I really hope it's not this. It's saying... Can't be this. Let me see if I can fix this for y'all. PMOS. Delete this. And you know what extreme thing I'm about to do right now? I'm gonna get rid of that sub. It's gonna bark at me. Do you know why? Symbol. Get rid of that sub. Now it won't bark at me. Okay. This is me using my engineering brain. Oh. Ah, it didn't like that. Copy paste. Boom. Sub. Boom. Boom. Let's get rid of this. Because we don't have a sub in here. So let me just LVS it again. This, I think, should fix the problem. Basically, it's saying it exists in the layout, but it doesn't exist in the schematic. And that's true, because we drew a metal 1, and it exists. Sub, the pin is connected to a metal. Let's see if my philosophy is working. Oh, yeah, baby. Let's go. Did everyone understand that? Did you understand what just happened? No?
I'm trying to add that today.
So basically what I'm saying is I'm having a big war with this resistor or this thing, okay? What I'm assuming the investigation that I'm having, let me see, schematic, is that every component is somehow affected by sub even though it's not connected to sub, right? This sub is floating or it's being affected, but it's not like doing its thing. I'm not going to put a dedicated pin because the pin, like the pin is something like in the net list. It's like a physical thing in the net list, something you type. And if I tie that to a metal, it says that's connected. The pin is connected to a drawing, right? But for some reason, this resistor, even though it doesn't exist, that third terminal, because I declared a pin in the layout, it said it does exist in the layout. It doesn't exist in the schematic. It's telling me in the schematic it doesn't exist. But I have to feed it this. So how do I fix that? Just make it not exist here. Okay, so there's no sub pin, even though there's a sub label here. Or better yet, you know what? If I just delete that, I think it should fix some other problems. All right? Any questions? Because I'm trying to hammer this big problem, okay? You see that V bias P? Okay, we just did PMOS times 5 again. NMOS should be okay, all right? These two pieces are okay. Get rid of that. Now I can work on this. Um, uh, thought I changed this. This shouldn't. Anyways, you guys like my rants? I went on a tangent there, huh? Let me do this. Actually, I'm lazy. Okay, I'm not move. Wait, was it V bias P needs to move away? Let me see. Give me a second. This is my current mirrors, right? This is my NMOS right here. How long is my NMOS? From here to here, 1. Okay, that's correct. Yeah, here's my V bias P. V bias P. Oh my goodness, I'm blind. Ugh. There you go. Okay, nope. Okay, anyways. What was I looking at, y'all? I'm gonna do the following, okay? This is where I need to be, right here. No more cheating. Move, boom, boom. Is that good with everybody? And then I can move this pin down here a little bit, okay? Then I'm gonna move this right here, move, boom, come down. S to stretch, boom. Is everyone, wait, oop. There you go. Move, boom. Everyone's gonna do this on their final projects. Cool. There we go. That should work. Should I run the DRC again? Sanity check. Doesn't hurt to do it LVS. Because I'm about to do the biggest circuit right now, okay? If you make sure everything at the bottom level is DRC clean and LVS clean, then as you build these Lego pieces, everything should follow. If something in the bottom breaks, everything gets affected. So it becomes a huge headache to figure out where the problem is. So, boom, okay, it's still clean, okay? Anytime you change something from the original schematic, please just LVS it, DRC it, and boom, that is clean. Like how flush that is? I love it. Anyways, so I'm gonna press save, okay? Because I'm gonna go back to my schematic, my current mirrors, create new cell view, schematic. Okay. What am I gonna do here? My library, my current mirror, right? What am I gonna do right here? My PMOS. Okay. Everyone cool with what I'm trying to do? So what pins do we have? Oh, P for pin. V bias N, right? V bias N is a pin. But it's gonna be queued. Let me do this. V bias is input output. Okay, it actually okay. Let me do it. Let me do it like this. V bias N. What's another pin? V bias P. Right? And then I have, there we go. I have VSS and sub. I'm gonna do this. VSS. No, that's sub. This is VSS. Okay, I'm gonna move this. Boom, this. Boom. I'm gonna queue this. Do you guys like my copy paste? Makes life a lot easier. VSS. So I'm gonna do the following. Maybe you guys see the pattern I'm trying to do. See? I'm mimicking my rail system. V bias N's on the bottom, V bias P's on the top, sub, and you see that? Then what am I gonna do with my next voltage. You guys like that? That's my rail system. Okay. How do I connect to it? Wires. Right? VDD. And then I encourage the copy paste, okay? What's this one? VSS. Oh, Q sub. Press this. Q V bias P. Q V bias N. Make sure the caps and the lower cases and the upper cases look good, okay? Save, okay? So now I have to start connecting things, okay? So let me do this. Should I be lazy or copy paste? Let me see. Yeah, I'm gonna be lazy. Watch this. You. Okay. Do you see what I'm doing, guys? Am I being late? Because I don't want people thinking I'm like, oh, we have a lazy lab director. I'm not lazy, okay? I'm just more efficient, okay? But we joke around, okay? So disclaimer, all right? I do work. I'm busy, and actually, I feel bad for neglecting this class a little bit, but it's more like they threw this class at me like at the week before, and I was like, you didn't give me time to create stuff, okay? So I don't tell me what I'm doing wrong, okay? I have controls, I have electronics, I have circuits, I have a discussion I had last night for signals and systems, and then I have my PhD. And funny enough, I haven't been accepted just yet because I'm waiting for one letter of recommendation from a professor, and I do a lot for them. And they finally submitted it yesterday, and I finally got accepted. They were just waiting for that letter. So you can probably see my little frustrations, but I'm not. Don't think of me as like, oh, he's always frustrated. I'm very chill, no BS. But just work with me, and I'll work with you. Okay. Want to make this class fun. But anyways, do you like my copy paste? Do you like how I prepared all this on the side right here? So all I do is just this and just boom, right? You like that, Dave? Yeah? You're gonna do this on your homework? You can be like, yeah, I'm gonna copy what David did. Like this. So now, what's his name? Wire things like this. Wire. And then what do I need to do with... Okay, so this is the hard part. Okay, and you tell me if I'm wrong. I want this one to be called P I out N Moss. Okay, yeah, I out N Moss. I out N Moss is going to be an input output. Okay. Hide. I'm going to put them right here. Okay. Do I want... That's fine. What am I going to do here? Actually, maybe I'll do it like this. I want to be very efficient, y'all. There we go. Okay, I'll do it like that. Ooh, maybe I'll do it like this. Okay, then I want to copy paste it like this. Give me a second. Because IREF NMOS is something different than IREF PMOS. Let me look at the layout again. I need to think about this. You see how come on. Okay, come on. There we go. You see how I out is just existing on its own right there? It's just its own entity. And you see how this other this is my PMOS, right? Okay. Wait. here's I out right there. It's existing as its own entity. Is that cool with everybody? So they're not connected, okay? So they're all unique. Same thing with iref. You see iref right here? It's its own thing, right? Same thing with this iref right here. It's its own entity. So you have 4 unique pins, right? There's unique pins, okay? That's what I'm trying to, that's what I was like brain farting for a second. So I'm going to do the following. I ref, okay, nmos, I ref, this was pmos x5, right? Is that cool? And then what am I going to do with this one? I out nmos, I out pmos x5. And then what am I going to do here? Copy paste. L for label. I ref nmos. And can I copy paste? Maybe I should have copy pasted. Nah. No. I ref pmos x5. Can you copy paste? You guys like the copy pastes? When they're clean. I out and I out. Okay, this is the bonus homework, by the way, okay? This is what you're going to be doing for your bonus. If you want to, you don't have to, but you'll probably need to know this, okay? And then what's the last thing I'm going to do? Dave, maybe if you were smarter. It's okay. I should have done it the lazier way. Wait. Oh. M for move. Oh no. Okay. Come on. C. Right here, right? That's my NMOS. This right here is my PMOS reference, right? And then this right here is my boom output NMOS, right? Gosh, this is gonna be so beefy, y'all. And PMOS. Everyone see what I just did there? Woo! Check and save. That's a lot of work. What's the next thing I'm gonna do? Create cell view from cell view. Okay it. What's on my left? Nothing. What's on my right? I'm gonna put all my outs. Okay. I'm gonna cut this, paste this here. You know what I'm gonna do? I'm gonna put these on my as my left pins, whatever. Okay. V bias P and V bias N are gonna be on the top. VSS is gonna be on the bottom. X. Sub's gonna be on the bottom too. Okay. And VDD is gonna be on the top. Does that look good with everybody? Tough, huh? You guys like that? You guys like how Cadence just pops out like the symbol? And personally, don't do anything crazy to this, okay? I think I like it like this. Check and save. Check and save. Okay. My current mirrors. No, not copy. File, new, cell view. Sim underscore my current mirrors, create a schematic. Okay. I to instantiate my current mirrors, hide. Guys, I'm king of copy paste, y'all. I'm gonna do the following. Where's my simulation? Is this cool with everybody? I'm going to copy paste this. Copy paste. Ah, I see what happened. Okay. V bias NMOS. So NMOS needs to get this bias right here, V NMOS. Okay, so NMOS needs to have this. Copy paste. Okay. Boom. Okay. And boom. Is that good for everybody? But now I need to do the PMOS because I don't think I showed you the PMOS yet. V bias N is just this guy right here. So copy this right here just for my sanity check. V bias N. Cool. So that was my NMOS. V bias N, V NMOS, VDD. I out. Okay, let me just see something. The output of the NMOS goes to VDD. Boom. Is that good with everybody right there? So I'm going to exit out of there. I'm going to look at something else. I'm going to go to my PMOS. Sim my PMOS right here. Times 5. What did I do there? You guys like how I'm just putting things together? You see how I out and IREF are grounded for the PMOS? Right? So what am I going to do here? Copy paste this ground. And then where is my PMOS output? Or ref? Is that cool with everybody? Copy paste this. There you go. Do I like messy circuits? Yeah, sure. That's so messy. Whatever. You can complain to me later. Is that cool with everybody? And then VSS and sub. Oh, I don't like this. Oh yeah, because the PMOS we didn't do that. No. Okay. Sorry. Let me go back to my NMOS. Should have seen what I did there. VSS and sub are grounded. I just needed to make sure. Okay. Boom. And boom. Is our thing working? Is that good? Is that a good simulation right there? Check and save. Uh-oh. Oh. Okay. Guess what I gotta do here? I'm gonna connect VDD. Copy paste. Boom. 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 Can't get copy paste. Boom. Label V bias N. Label V bias P. Is that a good simulation? Launch ADEL. Session. Load state. You see the problem right there? Do I have a session to load? No, I don't. But let's create it from scratch. It's okay. Is it okay? Nah. Okay. How did I want to do this? I think it was analysis choose because I want to teach everyone, okay? Let's do 1 nanosecond simulation. Conservative. Boom. What are the outputs to be plotted or saved? Select on design. What do I want to see? I want to see the output currents, right? PMOS right there. Here's my NMOS right there. And then, yeah, let's look at the references. Boom. Boom. And then, you know what? Let's look at V bias P and V bias N. Is that good with everybody? Escape. Boom. And run. Oh, yeah, baby. Let's go. It's running. It's running. Oh, yeah. Let's go. And then How do I separate this by family? Split by family. That's not what I wanted. Okay. Split by trace? Anyways. What's V by SN? 800 millivolts? What about V by SP? 300 millivolts, right? So you can use these voltages to bias something. What's the current of V IREF NMOS? 19. What about IREF PMOS? Negative 19 because the current goes down, right? What about I out NMOS? 1-to-1, 21 micron, because we made a current mirror 19. It's a 1-to-1 NMOS current mirror, right? But I used the times 5 PMOS right here. What should I get? Negative 107 multiplied by 5. Yeah? Everyone see how cool this is? So this is the bonus question. Do you think that... I usually give like 1 point. Should I give like 2 points? Does it really matter? I don't think it does. Point is, this is good information to know. Okay, I'm not. Point is, you don't have to do this. If you choose to do this, that's for your personal enrichment. Okay, but if you do this, it's like a good thing to learn. Like, oh wow, so that's why I'm not forcing you guys to learn this. But if you want to, the bonus is the enrichment of me teaching you guys. Okay, everyone's gonna get an A. I'll tell you that. Well, if you bomb the project, you will fail. Okay. So make sure you do the project. If you're getting an LVS error or a DRC error and you're not fixing it, you're not gonna pass. Okay, I'm gonna tell you that straightforward. If you turn in a final lab project report and it doesn't pass DRC or doesn't pass LVS, unless you have a really strong justification, that's we're trying to build things here. Okay, we're not trying to make a failing product. All right. Is that fair with everyone? So what does that mean about the final project? Make it simple? Well, not like simple like a voltage divider. Something cool, okay? Here's some projects. Actually, later. I want to show you something. Okay. We're done with the simulation. Get rid of that because I definitely want to talk about the final project. Save state, so I don't have to do this anymore. What am I going to call this? Current mirrors. Yeah, there you go. Save, get rid of that. Because I want to do the full LVS, or not LVS, but the layout. Get rid of that. What is this? My current mirrors? Okay. Come on. Don't you just like it when Cadence does stuff like this? There you go. I think I know how to fix it. If you just press this and then press like expand window again, it like somehow resets it. Okay, I think I figured that out. All right, let's pull this right here. Oh, come on, pull this right there. Let's grab my library. My current mirrors schematic. Okay, so this is the hardest part of the day. Okay, it's making me think of things too. What pins do we have? VDD. So VDD, right, is going to be on metal 1. Cool. Check. VSS is going to be on metal 1 right here. And here's the problem, and this is where I'm seeing things. Sometimes you're gonna get like actually you see how they have two double labels like that, and I've seen this a lot in my internship. There's a way to fix it. You can do the following: Control P or Control P. If you just get rid of this, keep first name, it'll disappear from the original schematic. So like let me show you what I mean. So this is my NMOS right here, right? NMOS, current mirror NMOS layout, okay. And if I just go back to this, delete it, Control P, VSS, and do not keep the first name. Okay, so now it just exists like that. Get rid of that. I guess it's still there. Anyways, this is the physical only. Never mind. VSS, and you're gonna do the following. I guess I'll keep first name, whatever. Create a rectangle here, and do your very best to match it like that. Did you see that? What I just did? Just place it on top. Okay, makes it easy. Okay, now I'm gonna do Control P, subscribe. Click on this. Q this. What was the height of this? It was like 0.7. 0.6. Now you see. Now you have to create your own standard. Oh God. Was it 0.6? No, it can't be 0.67. I'm not that cringe. 0.8. There we go. Does that look cool? Anyways. Check. V bias P. Right? With right here, right? I'm gonna Q. So create pick numbers that are easy. I'm gonna do 0.5. 0.5. Okay? 0.5, easy. Boom, go home. Okay, this one's gonna be funny. V bias N. Okay. Okay, escape. Q that, and I don't know, I'm gonna guess at 0.6. Oh, I guess they're right. Did you guys see that? M. I hit the money. Anyways, everything's connected now. You see that? I got all these power rails. Look at this power rail. You see that? It's all connected. You guys like this class? No, man, it's boring. IREF NMOS. Where's that? Here's my NMOS right here, right? Where's my ref? Right there. I'm going to do Control P. Oh, come on. Control P. IREF NMOS. And then I'm going to put it right here. I'm going to cue this right here, and I'm going to, oh, come on. And I'm going to, okay, come on. Cue this, and I'm going to put this as 0.1. Okay. It's nothing too important. Okay, is that good with everybody? What about IREF PMOS? Where's that one? Right here? IREF PMOS X5. Correct? Put it right here. Oh yeah, there's a thing that some engineers do. You see how this rectangle right here in the middle is like a pin? So some people like putting pins inside of other pins. Like you see this right here? A pin inside of pin inside another metal. It's like a good indicator, like, oh, why did I draw that square? Oh, it's a pin. Okay, that's what I do. You may have something else that you want to do, but that's how I do it as a designer. Okay, 0.1. Okay, so look, basically what I'm saying is, oh, what is this? Oh, this rectangle has a purpose. What is it? Oh, P6. And then if I wanted to double click, I'm not going to do that. Oh, by the way, save. All right, cool. I out NMOS. We're almost done, everybody. We're almost done. And then we can run this puppy and go home. Where's I out? Right here. Okay. Control P. Ah, oh, gosh. I'm so excited, everybody. I out NMOS. Because we took care of all those dumb resistor rules. Oh, come on. Q. 0.1. Is that good with everybody? And now I have to do the last one, I out PMOS. Okay. I'm sweating, everybody. I hope this works. PMOS X5. If this doesn't work, I'm just gonna start announcing the final project. Be like, I'm angry for your final project. Flag. There you go. And that's it. Do you see how cool that was? We just connect. Well, they're not directly connected, okay, but everything is now one big piece. Is that cool with everybody? I think we're ready to LVS this. Let's DRC it. Submit. Let's go. Come on. Hope I don't get stream sniped. I'm out though. Wow. PogChamp. What should I use? I'll use these later. Woo! DRC's good. That means we drew everything correctly. Okay? Pegasus. LVS. Man, if some random like what do you call it, user is probably like hovering down the just chatting, or Mr. Beast did like a thing like, let me look at channels that have no subs or nobody looking. Imagine he looked at this, he's like, whoa, this guy's I should give him $1 billion. I'll be like, guess what I'm gonna do with that $1 billion? Buy you guys a bigger lab. I don't want that money. Well, I want to eat. Nah. Nah, there's some stuff I want to buy. I want to buy some characterization tools. I want to buy a beautiful connection to like TSMC, and look, I'll make some good money here. I need a probe station. I need a dedicated PCB not milling machine, like a whole fabrication. Oh, I wouldn't care about the salary at that point. Yeah. Well, I do need money, but anyways. Okay. Where is it? What do you think it's gonna say? Oh. Okay. In the layout, it says it's a short. In the schematic, it says it's a wire. Where is this wire? Come on, baby. What do you think it is, y'all? I thought I would have fixed this. I thought it would have worked. It's shorted in the sub, or the sub is shorted in the layout. Schematic pin. It's its own net. What does that mean? Please don't be this error. Oh no. I hope it's not this. Oh no. It doesn't like that. It wants it to be its own sub. It's this darn resistor. It's this pesky resistor, everybody. It says it says in the schematic I gave it a label. This one is just floating. Control E. Double click into this. Open. Sub. And this is shorted to this. No, that can't be it. Because when I short the sub to the sub, I talked to this buddy of mine, and he said something about there's a way to force this thing to not be sub. My dilemma is this. Because this sub pin exists, it's a wire, right? It exists in the layout and it exists in the schematic. Correct? Here's my PMOS times 5. This sub doesn't exist. But if I put a pin in the layout, it's going to cry saying, I exist in the layout, but I don't exist in the schematic. You see my problem? Because let's say David does this. Okay? And I force this to be my sub, okay? Because technically I should have a sub, but I don't. Right? Right? And then it's going to cry at me. It says, hey, you can't do that. And I know why. Because you got to go to the symbol, correct? Extra work for me that I don't want to do. Copy, paste. How do I rotate? Oh, there we go. Press R to rotate. Press on this red box. Sub. Cool. Now check and save, correct? Everyone's witnessing this dilemma I'm having. The sub now is there, but there's no way to connect to it. There's probably someone like, oh, this guy is crazy. I'm like, I know. So I'm going to go back to my PMOS, right? And I'm going to declare it. Control P, sub. And which one was my sub pin? It was this guy right here. Right? But it's not connected at all to this resistor. Unless there's like a way to, like, unless like I have to tap into it. But I don't know what to do. I'm going to Pegasus it again. I'm going to LVS it. I'm going to submit the LVS and watch it not work. This will not work. Unless maybe I am crazy and I slept good. I slept 7 hours. It feels nice.
Is there something in the properties of the resistor you can enable?
I'm trying to figure that out too. I gotta tell that this resistor isn't connected. It shouldn't be. Here's my PMOS. See? It says it exists in the layout, but in the schematic, it's an open. So I have a dilemma for y'all. Oh, this is going to be a bad one. I really don't want to do this. I really don't want to. I hope it's not this problem. Please don't. Because this is not how I want to teach. Are you seeing what I'm going to do right now? Oh God, I really hope it's not this. Please don't. Don't do this to me. Pegasus, LVS. If it runs the LVS on this, I think I have a lot more things to like question. This should fail. If this passes, that's a bad thing, and I don't know if I want to do that. Can an LVS happen at the lower, like, can an LVS at the top layer happen if the bottom layers fail? That's not what I was taught. Okay. Did it run? It ran. I don't like that. I really don't like that. I don't like that at all. And I think I need to investigate this problem a lot deeper, because I think this is from the week 2 or week 3, that lab 1 or lab 2 with the PMOS soft check. Maybe that is the root. Okay. Something I don't like this comparison. Yeah, it checked there. The LVS failed at this level. Let me see. Current mirror. PMOS times 5. LVS. Guess what I'm gonna, should I, no, I don't want to run it like that. Just run. I'm having a dilemma right now because it would be nice to have everything LVS down the chain. You see, that's not good. Because you know what I want to do on the schematic? I want to put like a dummy thing, like a dummy component to satisfy this. So you know what I would want? If someone wants to investigate this for me, be my very guest, because this right here is like, this right here is like, I think this is like an industry problem now. Find a way to tie this to an NMOS body without it. It might like put a dummy or something. Like, is there something here in this layout? Not this layout. Where's my other layout? Is there any way I can tie this sub somewhere on here without like adding additional things? That's what I want to solve, right? So you know what I'm thinking? I think because of that PMOS error, like, oh, that P-tap, oh no, I think. You guys mind if I do something weird? I don't know. This shouldn't work. This right here is a P sub tap. And let me make it bigger, okay? 3 by 3, because this right here is like a rhetorical question. It's like, is this the right way to do IC design? I'm going to stamp that there. Now there's a physical stamp to my PMOS, right? This is going to run DRC. Let me just run DRC, okay? But that's just the layout. But how do I introduce something in the schematic to say it's okay to float, even though NoCon didn't work, right? That's the thing I'm trying to present to everybody here. My LVS runs. Here's my DRC run. And you see it fixed it right there, right? There's no... Let me show you that I ran the PMOS. Do you know... You see current mirror PMOS 5, right? The DRC fix. Remember that bonus question from lab 2? How do you solve that problem? Just put metal 1 to the P sub. That's the answer, okay? So a few of you guys did that. I'm shocked that a lot of people didn't do it. But yeah, that's how you fix that problem. But how do I tie this? How do I draw this in my schematic? If I can figure that out, see, this is where I get frustrated. I want to design labs so that they're right the first time. Where's my schematic? What component can I use to mimic this sub? Let me just look at my library, okay? Let's go to GPDK. Not MIM, no. None of these components are going to do what I want them to do. And if you remember that thing we did on, what's his name? Did I give you guys that folder? I don't think I did. I don't think I did. Or maybe this was it. Sorry, give me a second. Here's all the pieces available. What can I instantiate as a physical component to the... Yeah, like, see, this one tells you every component. Let me just scroll to the bottom. Yeah, you see it tells you every piece, like what they do. You see this right here? Let me zoom this out. Every component in this process. But how do I mimic a tap or a dummy without introducing unnecessary layout? So I think what I'm about to say right now is, in reality, designers don't actually do what I like. I'm making myself sound really sad right now. You know how I made you guys do like a current mirror PMOS or like my PMOS 2045, right? And you would assume the baby building blocks will work. What I'm trying to say is, don't do the Lego piece. Well, you shouldn't try to do the Lego pieces, but I would love for you to like experience that as a theory, right? Point is, the theory is not working. We got to start making money, okay? So what I'm trying to say is, current mirrors, usually you have an NMOS tied with a PMOS, okay? PMOSs can't exist without something pulling them down. There's no reference. So you want to know how I would have fixed that problem altogether? Instead of making you do like a PMOS current mirror separately and an NMOS current mirror separately, is you put them all together as one big PMOS NMOS. That would have avoided the whole situation entirely. I just put a tap in there. Did I run the LVS again? Did I? No, I don't think I did. But I have the window open. Let me see. Right here, right? Right? Let me run that Pegasus again. Because right now I'm just because that means I'll have to redesign a lab for a little bit funny now. Because this is very important, okay? This is the reason why I didn't get to publish it on time, because I wasn't confident. I won't give you guys something I'm not confident with. This is going to fail the LVS. And let's see the failure. Well, maybe I'm a good professor. Just, you ever forget a semicolon at the end of a line? So maybe I am a good teacher. I just, I like seeing that right there, because this is a confidence booster, okay? I'm trying to teach CMOS, not EDU, but CMOS here at UNLV, to make sure you guys take this knowledge, go have fun in Dr. Ming Zhu's class, okay? So you know what the answer was, and I think I need to force this. It's not a bonus question. I'm going to force this in my lab too. Not that one. Don't forget to stamp the peace up. Oh! If I just did that from the very beginning instead of having it an option, and then look, the DRC, it runs. Right? That how to fix that P sub problem is to put a P tap. It was a warning that affected the LVS. That's interesting. Don't you just love cadence? And I want you guys having fun with cadence too. I want you, if you could do more research with us. We just hired a new professor. Hopefully they sign the contract hopefully by tomorrow. So we're gonna do some RFID IC design with a real process. So if you want to work with more of this stuff for a master's or PhD, we have that here. Okay. If you go to Apple, Micron, NVIDIA, and want to do more of these funny headaches that are memories in your core, boom, clean DRC, clean LVS. And you know what? I'm going to just do this for my sanity check. Here's my master DRC. And I'll end it right here. Well, before we do the LVS. Was this a good worthwhile? I think so too. Oh, did it finish? That was quick. Not that one. My Kermiers, clean. And now let me go to Pegasus, LVS, because I want you guys being strong designers, okay? I want you knowing how to fix these problems when you go to your interviews. How do I fix this? Okay? Now here's the goodie part of the day. Let's watch it pop up. When I click on it, sign off. Come on. Pop up. Pop up. There it is. Come on. Click it. It's a little heavy. Any questions, everybody? So yeah, this is lab 4. That was so intense. I can write a full document for you guys with 100% confidence. Okay? I'm still not forcing that bonus question, but now you know how to do the bonus question. Lab 5 is going to be multi-channel things where you have, I want to copy paste a NAND gate 8 times to make an 8-channel NAND gate. You know how we have, it's called, I think it's the 4001 or not 4001. It's the 7004s, 4-channel NAND chips, right? And you can build a little wafer for that. Or like, have you ever pulled out a chip right there and it has, there's 8 inverters in this chip. I want to teach you multi-system things so you can print little things at Texas Instruments, okay? So that's lab 5 and that's the end, and then we can start talking about the final projects. Any questions? All right, everybody, have a good day. Okay, and